In this video, we perform a read operation using Spring JDBC and display the data retrieved from the database. First, we create a package named beans, and inside this package, we define our beans class. This class will hold the properties that represent the fields of our database table. On the beans class, we add the @component annotation. This tells Spring that our beans class is a Spring managed component, making it eligible for dependency injection throughout the project. Now inside our beans class, we define three variables: ID, name, and balance. To properly access and update these variables, we create their getter and setter methods. This follows the concept of encapsulation in Java, which ensures that our data is secure and can only be modified through controlled methods. Next, we organize our project structure by creating some important packages, interfaces, and classes. First, we create a package named service, and inside it we define an interface called MyService. Then, we add another package named ServiceImpl, and here we create a class called MyServiceImpl which will implement the interface. Similarly, we create a package named repository, where we place an interface MyRepository. And finally, we add a package repository_impl, inside which we create a class MyRepository_impl to provide the actual implementation. This layered structure makes our application more organized, maintainable, and easy to test. Now, we move to our MyServiceImpl class inside the ServiceImpl package. Since this class provides the actual business logic, we annotate it with its service. This tells Spring that our class is a service component, and it will be automatically detected during component scanning. By marking the class with its service, we make it eligible for dependency injection wherever the service layer is required. Next, we go to the MyRepository_impl class inside the repository_impl package. Since this class directly communicates with the database layer, we annotate it with @repository. This annotation tells Spring that this class is a data access object, DAO, and is responsible for database operations. We use the implements keyword. So, our MyRepository_impl class will now implement the MyRepository interface. This ensures that whatever methods we declare in the MyRepository interface must be provided with a concrete implementation inside MyRepository_impl. Next, we work on our MyServiceImpl class. We already have an interface called MyService inside the service package. Now, our MyServiceImpl class should implement this interface to provide the actual logic. To achieve this, we use the implements keyword. By doing this, we ensure that all the abstract methods declared in MyService must be overridden and defined inside MyServiceImpl. Now we create a function called loadAccountData. The purpose of this function is to fetch the account details such as ID, name, and balance from our service layer and display them to the user. Now we are going to create a function named loadAccountData. This function will fetch account data whenever we click on the Show button. Now we are creating a controller method to fetch account data. Inside the method named loadAccountData, we create a new model and view object, passing common as the view name. Now we move to the MyRepository interface. Inside this interface, we declare a method called getAccountData. This method returns a list of maps, where each map contains key-value pairs representing account details from the database. Now let's save the interface and move to the MyRepository impl class. Here, we implement the MyRepository interface. Since the interface contains abstract methods, the implementation class is responsible for providing the actual logic. So, inside MyRepository impl, we override and implement the getAccountData method. Next, inside the MyRepository impl class, we need a database helper to execute queries. For that, we use the JDBC template class provided by Spring. We declare a private variable of type JDBC template and annotate it with @AutoWired. This tells Spring to automatically inject the JDBC template bean that is already configured in our application context. Now, inside the getAccountData method, we write a SQL query to select the ID, name, and balance columns from the account data table. We then use JDBC template.queryForList SQL to execute this query and return the result as a list of records. Now, navigate to the service layer. Here, we'll write the method getAccountData. This method will fetch all account information from the database. Next, we move to the service implementation class. Here, we need to implement all the abstract methods declared in the service interface. Now, in the service implementation class, we inject our repository. We use the @AutoWired annotation to let Spring create the object of MyRepository automatically. This way, we don't need to manually instantiate the interface, and Spring handles all the wiring for us. Now that our repository is injected, we can access its methods directly. To fetch account data, we simply call repository.getAccountData and return the result. This allows our service layer to retrieve data from the database through the repository, keeping our code clean and well-structured. Now, let's move to the loadAccountData controller. Here, we'll prepare the model and view object to send data to the view. First, we add a flag called process with the value showData. Next, we call service.getAccountData to fetch all account records and add them to the model with the key data. This way, our view will receive the account data and know which process to display. Next, open common.jsp. We'll use the JSTLC if tag to check if the process attribute equals showData. Inside this condition, let's start simple and display only the name field from our account data. This ensures we first test the data binding before showing the full details in the view. Now that all the code is in place, it's time to run the project. After running the project, we notice that the data is not displayed on the page. This usually happens due to an error in fetching or binding the data. To solve the error, open the browser's Inspect mode and go to the Network tab. Look for the red-colored URL indicating a failed request. Click on it, then check the Preview section to see the exact error message. This helps us understand what went wrong and where to fix it in our code. Now, looking at the payload, we see the error message, demo.account data does not exist in the database. This means that the table account data is missing in our database or the name doesn't match the entity configuration. The error occurs because the account data table exists in the test database, but our application is currently configured to use the demo database. Since the table isn't found in demo, we get an error. To fix this, open db.properties and change the database name from demo to test. This ensures our application connects to the correct database where the table exists. After updating the database configuration, we run the project again. Now, the data loads successfully, and we can see the name field displayed on the page. This confirms that our service, repository, and controller are all working correctly, and the view is receiving the data as expected. Now, in common.jsp, we design a full table to display account data. Inside the cif block, we first create a container with padding and a background. Then, we add a heading account data. Using an HTML table, we define headers for ID, name, balance, and actions. Inside a less than cif for each loop, we iterate over each row of the data, displaying the ID, name, and balance in separate cells. For the actions column, we include update and delete buttons with JavaScript functions to handle these operations. The table also includes hover effects and responsive styling for a clean, user-friendly interface. Now, open your browser, reload the page, and click on the Show button. This will trigger the controller to fetch the account data from the database and display it in the table we designed. You should now see all account records with their ID, name, balance, and action buttons on the page. That's it. We have successfully fetched account data from the database, displayed it in a dynamic table. If you found this tutorial helpful, don't forget to like this video and subscribe to the channel for more coding tutorials and tips. See you in the next video.